So simplifying exponential expressions. Basically, we're going to continue on what we started last time. Today, we're going to do more complex examples with more variables and numbers. So simplifying exponential expressions, basically using these rules that we learned, okay? So far we saw a variable here, one here. Today, we're going to see what happens if you have two or more variables here, two or more here, multiplied, same with the fractions. So multiple variables over multiple variables, maybe some numbers, maybe parentheses to the second power and so on. So that's what we're talking about today. Simplifying exponential expressions using all those rules. So the first type of examples, let's say if you have, let's say 2x y times 3 xy, maybe some powers here, 2, 5, 4, and maybe 3. Basically, we're multiplying this. This is a multiplication by this. Or sometimes you may see parentheses like this. That means the same thing. That means this times this. So if you recall from last time, so which rule from these are we going to use to multiply that from this list? Which one, which number do you think are we going to use to multiply these two expressions?
Would it be the first one?
That's right, it would be rule number 1. So when times base, same base, different powers, just add the two exponents. Okay, like I said before, there could be here just one variable, or it could be multiple here, but the rule is the same. It could also be numbers like here, for example, we have 2 and 3. So those are just regular, those are real numbers. They're coefficients. They're not powers, it's just regular numbers in front of these variables. So we're going to multiply those first. We're going to say 2 times 3. This 2 and this 2. Then, what else do we multiply together?
X.
That's right, we're going to multiply the x's together and also the y's together. Because to use rule number 1, we need to have the same base in order to be able to add the two powers. So first we're going to write them next to each other. So we're going to write times x and x. So x2, x4. And then y5 times y3. And so that's 6. And what is x2 times x4? x2 multiply x4 will be?
X6.
Right, x6. According to this rule, we add the powers. x6, then y to the power 8. That's right. So that's it. That's basically the answer. You don't even have to write this step. You could skip it. Just do 2 times 3, that's 6. x2, x4, that's x6. y5, y3 is y8. Okay, so that's basically how you multiply expressions like this. Sometimes you may even have something like this. Say 2, and we want to times this by 5. X maybe say 3, and y minus 1. So that's another example of multiplying algebraic expressions with multiple variables. Same rule, same method. What is this equal to?
-20.
That's right. First, we're going to multiply -4 by 5. It's -20. And then x times x3. What is the power of this x?
1.
That's right,
1.
divisible 1. So if you times x1 and x3, then we're going to times y2 and y negative 1. So first let's start with x1 times x3 would be
4.
4, that's right. And what is y2 times y negative 1?
Just
1.
one.
That's right, we combine these two, minus 1, that's 1. And that's it. That is the final answer to that, okay? So if you don't see a power over a variable, that means the power is an invisible implicit 1, okay? And powers could be negative, could be positive, as we discussed here in detail the other day. So it could be both negative or both positive. So just combine them, negative 3, for example, and 7 is 4, and so on. And it doesn't matter how many variables you have. It could be 10 variables here, 10 here. It's the same thing, just multiply and combine or multiply the like variables and add the powers. Now let's look at fractions. So fractions work like this. Let's say x and y, x, y, maybe some powers here. Let's say 5, 2, and 4, maybe 8. Okay, so you want to simplify this, try to make it shorter if possible. So again, which rule from the list we're going to use from this list?
2.
Rule number 2, that's right. Whenever you see fractions, same variable. So we can simplify those by subtracting the powers, as we saw last time in these examples and this rule. So subtract the like powers of the like variables. So here we have x over x to the 5th over x to the 2nd, so it'll be x 5 minus 2. And then you have y4, y8. So we're going to subtract those two. Notice that we no longer have a fraction here. You can say just 1, okay? Because we subtract them, the fraction is canceled. Sometimes if there's a number, it may stay here. If you have, for example, 3 here or something, that number could be here. But for now, it's an invisible 1. You can say like this. So this is x to 3rd times. This will be y2.
The negative 4.
That's right, negative 4. And as always, we don't want negative powers. So what happens to this one?
You would put the y to the negative 4th on the bottom.
Exactly. So we're going to bring this down to turn it positive. This doesn't need to be moved. It's already positive power. So this turns into x3, y4. Remember, your answers should have positive powers only. Okay? So always make your powers positive. So that's one example with fractions. Let's do another one. Sometimes you may have fractions here in addition to the variables. So you could have this and maybe some other variable. Let's say, for example, x here. Say 4. And maybe y negative 1 over y 2. Okay, so we want to simplify this as much as possible. Notice that the first one, look, it looked like this in the beginning, and once we simplified it, it looks much easier, much simpler. Same thing with this, it turned into this. Now we have to do a few things here to simplify this. What do you think we do first? What do you think we do first to simplify this? First, look at this fraction, 15 over 35. Can we reduce that fraction?
Yes.
That's right. So we're going to look for the highest number that can go into both. What's the highest number that can go into 15 and 35?
5.
5, that's right. We can say 15 is 5 times 3 over 5 times
7.
7. And later we're gonna cross out the 5. The fraction turns into 3 over 7. And what do you do with x4 over, what's the power of this x again?
1.
1. So what do you do with these two? x4 over x1 would be?
3.
That's right, x4 minus 1. Again, using rule number 2 here, we subtract the powers. Then we have this power that's negative. We have this one. You could do -1 minus 2, which would be -3, and you still have to move it down. Or how do you make this one positive again? Before we use it, we want to make it positive. So
You would move it down.
exactly. So we're going to move this over here, down next to the other variable. So it turns into y2. And this y -1 turns into y positive 1. So whenever you see a negative power, before you start doing anything, turn those powers positive first. Unless you have this case where you multiply the powers, unless it's this case here, something like this, then you may want to multiply first. Don't turn anything positive because they may turn positive once you multiply them. So if you multiply these two, they turn positive. That's probably the only case you don't need to, or you don't have to make them positive. But any other case, make all your powers positive first. It makes more sense. It makes it a lot easier to use these rules with positive numbers only. So now I can cross out the 5s. What's left is just 3 over 7. We have x3. What's y2 times y1? The times here will be?
Y to the 3rd.
That's right. So it's no longer a division here. It's no longer a subtraction because we moved it. Now it's next to it. That means it's a multiplication here. So when you multiply, we add the powers, not subtract them, because we moved it next to the other number. And that's basically how you simplify fractions and exponents with numbers. Now we're going to add another thing to it. Make it a little more interesting. So if you have x, let's say 7, x here, 3, y 5, and y2, for example. And another power over the whole thing. Let's say that power is maybe 6. This one, what you do is, so we have a lot going on in addition to the power outside. So always work inside the parentheses first. When you see a power here, don't worry about it for now. Could be negative here, could be positive. Just work inside the parentheses, and later we'll see what to do with that power. So what do we do inside the parentheses? So we need to, write this, keep that power there. Inside we need to subtract these, so x7 over x3. If we subtract the power, that will be x4. And here, y5 over y2, if we subtract, would be y3. We don't need that fraction anymore, as you can see. It's positive here, so we can just say x4, the whole thing, to the 6th power. We need to do one more thing here. We need to simplify this. Which rule from this list do you think we're going to use to do that?
3.
Could be 3, or could be this one.
7.
Yes, 7. This is what we have basically. We have something, two things, to the same power. So we're going to split these into two things, or we're going to distribute the a power to both x and y to get to this. So this 6 belongs to all this, so we're going to distribute the power to them. So we're going to use that first and then use number 3. So we're going to use 7 first to split them, then we're going to use number 3 to multiply the powers. So it'll be x to the 4th to the 6th. Basically, we're just splitting them. And then y to the 3rd to the 6th. Okay, so now what do we do with these powers? That's rule number 3. So we're just going to times a and b. So this will be x to the power
24.
That's right, 24, and y to the power
18.
18. Okay, so as you can see, we used multiple rules from the list. We used most of these. We used this, we used this one. So we used almost all of them. So just remember the main steps, and then in each one of those steps, you're going to be using 1 or 2 rules. So if you have parentheses and the power outside, work inside, and then do the power. Do whatever you have to do here. You may have numbers like this to simplify. You may have negative powers to move down. Depends. So when you work inside, you might be doing any of this. So do that. And later, after you're done simplifying inside, that's when you take care of the power. Just like PEMDAS, parentheses first, work inside the parentheses before the exponent. There's another example. Let's say, what just happened? So you have x, y, x, y.
Don't bring that here. First of all, if you was beefing at a wedding, you should have been beefing at their wedding. Why would you bring this to somebody else's club? That's fake.
So this to the power, let's say -5. Who's preaching? Romani? Is that you preaching? Okay, so x4 over x, y to the 2nd over y to the 7th, all to a negative power. Okay? Again, it doesn't have to look complex. Just follow the main 2 steps. So work inside the parentheses. Yes, this is a negative power. We're going to see what to do with it later. Here it was positive. We didn't have to do much, just distribute it. But we're going to do something special with this one later. But first, work inside. So inside let's make this a negative. So inside, we're going to have to first subtract these. There's an invisible 1 here. So that's x1. So x4 minus 1. And next to it, or actually we're going to move this one down. Okay, we're going to move this y -2 down to make it positive. So this y7 stays here, and y -2. All to the power still there. Don't worry about that power yet. You have to finish working inside first. So just leave the power there, -5. So here now, back to this, we have x3 and y2. Actually, this moved down, so it turns into what? Turns into?
Positive.
That's right, turns into a positive. Now y7 times y2 will be y9.
9.
Okay, so we're done working inside. There's nothing else to do. But we have this negative power. We have to do something with this to simplify it. Let's go back to the list of the rules. What rule? There's one specific rule we can use here first to simplify.
5.
That's right. We're going to use rule number 5 because we have a negative power over a fraction. We flip the entire fraction and the power turns positive. Once we do that, we can apply the power a to both of these. We can apply it just like we did in the previous example to both of these. Once we apply the power to both of these, it will turn to something like this, and then we're going to multiply the powers. Okay, so first we're going to flip this to make the power positive. It'll be y9 over y3. And the whole thing, this turns into a positive 5. Now, if we distribute the power 5 to all this, because 5 belongs to both these variables because of the parentheses, so this will be y to the power 9 all y to the power 9 all to the power 5 and y to the power x all to the power 5. So this is basically y45. So again, we have to multiply these, 45 over x15. And that's your final answer. As you can see, there is no negative powers, no number to simplify. These are different bases, so we can't subtract 45 and 15. These are different. In order to subtract them, the base must be the same. And that is your final answer, okay? This is probably as complex as you can get with this sorts of problems. But again, it doesn't have to look complicated. I know it takes a few steps, it takes a few rules, but each step and each rule in itself is not difficult to use. Just remember those main steps inside the parentheses first, and then deal with the outside power. As you do that, there's a bunch of rules you use. You have to decide which one to use out of these. Okay, does that make sense to everyone at this point? I want to hear from everybody.
Yes.
We have 15 people in the room, so please don't stay silent the whole time. Ask questions if you
Hi,
have
Professor.
engage.
This is Owens.
Owens?
Professor, quick question, because I came in late.
Uh-huh.
How you doing? Because I came in late. This is just a continuation from yesterday, right?
That's right. We continuation from what we started the other day. We're doing more complex examples, but I'll upload the video and you can rewatch the beginning of it later.
Do you hear me now?
Yeah, did you hear me? I
You
said
said this is a continuation from yesterday, Professor?
it is, and I'm gonna upload this and I'll watch it later. Yeah, your connection is pretty bad. It's cutting off.
Okay. Yes, I know, it's horrible.
Okay, but I'll
Thank you.
upload this later. All right. So let's do one more example with these, something like this. Make it a little more maybe complex. Add more stuff to it. So let's do this. Let's say x-1, 3, and y, say y7 for y11. We're gonna raise the whole thing to power. And there you go, simplify this. Looks fun, doesn't it? Does it look simple yet? So you have a lot going on, as you can see. But again, the idea is the same. You just have to remember your main steps. No need to panic when you see something like this. It's pretty simple, as you're gonna see. Just remember, work inside first. Forget about this for a moment. Once you're done inside, it's pretty simple to deal with this one. We're just gonna do what we did here. Flip it, make it positive. And when you work inside, we've already done that. Just pretty much something like this. So almost like this. Once we work inside, it's gonna end up like this with an outside power. That power is negative, then we're gonna do the same thing as we did here. Okay, so forget about this one, the outside power, just write it there. So inside the parentheses, what do you need to do? What's the first thing you wanna do?
Break down the 14 over 21.
That's right, we're gonna reduce 14 by 20 over 21. What's the highest number that can go into both?
7.
That's right, 7 into 14, how many times?
2.
2. 7 into 21?
3.
3 times. Okay, that's the first step. That's done. So that turns into 2/3. Now we have x to the third over x minus 1. What do you do with that?
Move x -1 to up. Yep.
Exactly. We're gonna move that up to make it positive. That turns into x3, x1. Now what do we do with these? Y
Minus.
7 minus 11. So let's continue working inside. Again, the power stays here. So we have 2/3. x3 times x1 would be
4. X4.
4, right? And 7 minus 11 would be,
-4.
that's right, -4. So before we deal with this one, let's first make everything positive here. One thing needs to be moved down. That's this one, right? Because we end up with a negative.
Yes.
Need to move it
Yes.
down to make it positive. Again, that -8 is still here. So 2 over 3, x4, and y4 here. This is a3. Or better if we do this. And finally, as you can see, now we're going to do the same thing as we did here. We have a -8 here. So this whole thing needs to be flipped upside down to make this positive. So it would be 3y to the 4th. 3y to the 4th over 2x4. And what happens to the power? It turns
Positive.
Positive.
okay. One last step, we're just going to distribute the 8 to everything that's here, because the 8 belongs to all these. So before we get disconnected, please, right after this, we're going to go over to Blackboard, okay? And join the discussion board. I'll add this also to the lesson plan, and you'll see homework. Now homework 3 is complete, so it's due next class. Okay, so right after this, we're going to go over to Blackboard. And we're going to discuss a few things there. I'll show you a few things and adjust some dates. Okay, now we're going to do 3 to the 8 power, y to the 4th to the 8th power. So 3 to the 8th, y to the 4th to the 8th, 2 also to the 8th. And finally, x to the 4th to the 8th. This probably is too big to simplify, maybe over 1,000. If it's over 1,000, just leave it like that. This, I believe, is 256, if I'm correct. If it's under 1,000, you can write it down. If it's over 1,000, you don't have to. What's y4 to the 8th?
Y. 32.
Not 32, that's right. And the last one, also.
32. Yeah.
Okay, that's basically how you simplify that. So it doesn't matter how complex the expression may look. So remember, with this kind of problems, work inside